Hello everybody, in this lesson I will explain two very difficult exponential equations. The question is solve for x. So the first thing that we will do, if we look at the left hand side of the first equation, you will find that these terms that are being separated by this plus. And this is where we're going to use our old knowledge where we factorize and we take out 3 to the x as a common factor. Before we do that, we're going to split the 3 to the x plus 1 up into 3 to the x times 3 to the 1 plus, and the other term 3 to the x times 3 to the negative 1. And now we're going to pull out 3 to the x as a common factor. So when I take out 3 to the x as a common factor, I'm left with 3 plus, and the 3 to the power of a negative 1 is the same as a third. And then 3 plus a third is 10 over 3. And now I want to get rid of the 10 over 3, so I multiply by 3 over 10 both sides, so that that can cancel out. And what I do on the left, I do on the right. And then the 10s will cancel each other out. 3 goes in itself once, and 3 goes into 9 3 times. So I'm left on the left-hand side with 3 to the x, and on the right-hand side, a third. And then a third I will write as 3 to the negative 1, and then bases are the same. Therefore, I can equate exponents, and the answer x is equal to negative 1. Now, on the second example, the first thing that we do is we're going to take the 9 and prime factorize. So 9 is 3 squared x minus 1. Now I want to show you something here on the right-hand side. If I give you a squared minus 1, can you recognize that sum? This is when you factorize, it's the difference of two squares. And then you can write it as a minus 1 and a plus 1. And very important here is when the original sum was a squared, your brackets are a to the power of 1 minus 1 and a to the power of 1 plus 1. And what I want to bring across is when you factorize, your factorized answer's exponent is half of the original sum. So when we go back to our sum, the 3 to the 2x minus 1, that thing is in fact the difference of two squares. And you can write it as 3 to the x minus 1, 3 to the x plus 1. And can you see this used to be 2x, and now the exponent is just x, because half of 2x is x. And now we can say 3 to the x plus 1 can cancel with this whole 3 to the x plus 1, and I'm left with 3 to the x minus 1 is equal to 80. And then the negative 1 will walk across, it becomes plus 1, and then I add 80 plus 1 is 81. And now on 81, I'm going to prime factorize, and 81 is the same as 3 to the power of 4, and then bases are the same, therefore we can equate exponents, and the answer x is equal to 4. Solve for x. Now it's x to the half plus 3x to the quarter minus 18 is equal to 0. So on the right-hand side, I'm going to show you something that is familiar. If I give you a squared plus 3a minus 18, and I say factorize that one, do you agree the answer will be a plus 6 and a minus 3? Now what happened? Again, your factorized answer, the a there, the exponent was 1. In other words, your exponent inside the factor, the bracket, is half of the exponent of the original sum. So if you go back to my sum, now you will find that thing factorized is x to the quarter plus 6, x to the quarter minus 3, because a quarter is half of half. And now you just solve the equation. So it's x to the quarter plus 6 is 0, and then or x to the quarter minus 3 is 0. So on the left, x to the quarter is equal to negative 6, and that thing has no real solution. Or x to the quarter is equal to 3. So what happened was the negative 3 walked across, and then to get rid of to the power a quarter, I times the power by 4 so that they can cancel out. And what I do on the left, I do on the right. And x to the 4 is 81. Therefore, your answer, x is equal to 81. And now I have a question for you. Have you subscribed yet? And can I also ask you a favor? Please tell all your friends about my channel. This is Miss Pythagoras signing off. Till next time.